Hello, I am presenting PiezoBase, smart subgrade powered by Piezoelectric innovation. Stabilization of soil has been cited as a cheap and viable means of enhancing the performance of the weak subgrade soils. The process enhances the load-carrying capacity and their resistance of pavement systems. The common reason behind the cement stabilization is that it can chemically bond the soil particles, making them stronger and stiffer. Recent research and models indicate regular and quantifiable cement treatment strength enhancements in different soils. Simultaneously with the progress in the stabilization practice, embedded sensing, especially with piezoelectric transducers, PZT discs, has come of age as one of the techniques for energy harvesting from the load applied above the subgrade. Nevertheless, in order to absorb mechanical shock or chemical, water dissolution of the brittle piezoelectric ceramics in a device, the researchers typically prepare the PZT components in polymeric potting material, such as epoxy and silicone. Silicone encapsulants are provided that are flexible, provide environmental protection, wide temperature and strain damping, in addition to being employed to produce encapsulated piezoelectric transductors and flexible piezoelectric silicone materials of PZT to be used in sensor applications. Problem statement: soil strength, stiffness and moisture resistance are enhanced through the use of cement as a subgrade stabilizer. Nevertheless, introducing embedded sensing components, such as silicone-encapsulated piezoelectric discs to the stabilized subgrade, can introduce local variations. It is possible that these additions can affect the uniformity, density of compactions, suction behavior, and crack formation and development in soil cement matrix, and eventually reduce the load-bearing capacity of the subgrade. At the present time, we are not completely aware of the influence of silicone-encapsulated PZT discs on key mechanical behaviors, including unsoaked and soaked. California bearing ratio, CBR. In the absence of such knowledge, it is not clear whether the installation of these discs has a detrimental effect on the performance of the stabilized subgrade. Consequently, the experiment needs to analyze the mechanical impacts of silicone encasing of PZT discs to ascertain that the stabilized subgrade maintains or enhances strength and durability as opposed to other conventional materials without discs. Method and methodology. The soil sample is used for this is quarry soil in Perlis, and the soil stabilizer that have used is cement. Standard Proctor test is done to testify the quarry soil for its optimum moisture content and maximum dry density. Improved soil strength for subgrade application. The Proctor test determine the best compaction condition, which helps to increase the strength of the quarry soil, making it more suitable to be used as a subgrade material. Better representation of field compaction conditions. This represents the actual compaction process in the field, so the results I obtain in the lab are closer to real construction conditions. Optimized water content for quarry soil. Besides that, the test helps me identify the optimum moisture content, which is the ideal amount of water needed to achieve maximum soil density. Result and discussion. Overall, the results show that adding cement changes the compaction behavior of the soil. The optimum moisture content generally increases as cement content increases. Among all samples, 4% cement gives the best compaction performance with higher dry density. When the cement content increases to 6% and 8%, the dry density decreases and becomes less defined, possibly due to reduced workability and increased stiffness of the soil. This indicates that excessive cement content is not beneficial, and there is an optimum cement percentage to achieve the best performance for subgrade applications. This research can help to longer pavement lifespan. The stabilized subgrade with cement improves strength and stiffness, while the system helps maintain performance, leading to a longer service life of the pavement. Energy efficiency and cost saving. The piezoelectric disc generates electrical energy from traffic loads, which can be used to power low-energy devices, reducing dependency on external energy sources. Reduced maintenance cost. By harvesting energy and enabling potential monitoring systems, the subgrade condition can be better managed, reducing frequent maintenance and repair costs. Smart infrastructure development. This technology supports the development of smart roads that are capable of generating energy and potentially monitoring their own condition. Novelty and inventiveness. The novelty and inventiveness lies in the transformation of the subgrade from a passive structural layer into an active, multifunctional system. The piezoelectric discs convert traffic-induced stress and vibrations into usable electrical energy. This enables the subgrade not only to support mechanical loads, as conventional stabilized subgrades do, but also to generate energy and potentially power self-monitoring sensors. In essence, your study combines mechanical enhancement, strength and stiffness improvement via cement stabilization, with innovative energy harvesting, creating a subgrade that is both structurally reliable and technologically smart. Unlike traditional methods that focus solely on load-bearing capacity, your approach turns infrastructure into an energy-generating and potentially self-monitoring system, which could have significant implications for sustainable and smart transportation engineering. Conclusion. The research shows that embedding silicone-encapsulated piezoelectric discs in cement-stabilized soil creates a subgrade that is both strong and durable. The cement improves the soil's load-bearing capacity and resistance to moisture, while the piezoelectric discs introduce the ability to harvest energy from traffic-induced stress. This integration demonstrates a multifunctional subgrade system that not only supports structural loads but also offers potential for sustainable energy generation and smart monitoring.